first of all, we are talking about the special right triangles, okay? So it is Common Core, G for geometry, and S or T for right triangles. Number 8 says basically we're going to use Pythagorean's theorem, which this does come from Pythagorean's theorem. Pythagorean's theorem, and I'm going to put special right triangles, special right triangles to solve triangles, okay? So these special ratios of x squared is 2 really do come from the Pythagorean's theorem. In fact, we saw that earlier when I showed it to you. I did x squared plus x squared. It will equal x squared to 2. Same thing with 3690 triangle, okay? I have to really emphasize the fact that, and I think I've done it already, it only works if it's a 45, 45, 90 triangle, okay? It only works. And this one only works if it's a 30, 60, 90, meaning that angle's 30, 60, 90, or you can turn it over this side and call it a 60, 30, 90, or you can turn it up this way and call it a 90, 60, 30, but either way, it's still the same triangle, right? Right, okay, good. So it only works if it's a 45, 45, 90, and only works if it's a 36, 90. If it's not, we're going to learn something else called trigonometry, which we'll learn here after we come back from break. We'll learn trigonometry to do any triangle, but trig is not hard. Okay, now let's take a look at example 1, okay? So example 1, oh, that's a bad picture. Remember, I can't draw, okay? But it doesn't look like half a square, but it is. How do I know it's half a square? Because of 45, right? Yep. 45, 45, so don't trust my figure, okay? Remember, I can't draw, I'm a lousy artist. So it is half a square, so 7. 7, right? It's half a square. And then this becomes 7 times the square root of 2, which is a number. I mean, what is 7 times square root of 2? It is 7 square root of 2. If you want a number like a 9.9, you can take that also. But 7 square root of 2 is a much nicer answer. You guys agree? You don't have to use your calculator. It's just 7 squared to 2. So as a math guy, I like this answer better because it's an exact answer. If you're doing some kind of a problem, you know, some kind of a story problem, or if you need to cut a board, you're going to have to actually get that answer. Does that make sense? This is a math answer that makes math teachers happy. This is the kind of answer that Marsons would want, right? If you go into Marsons and ask for 7 squared to 2 board, they'd think you're crazy, right? Okay. They'd say, smarty pants. Okay, example 2. Still 45, 45, 90, but it's a little bit backwards. Now, if the hypotenuse is 8 squared to 2, right, then the sides have to be 8 and 8. Okay, that would make this 8 squared to 2 line up with my triangle, so we got 8 and 8. Okay, does that make sense? Everybody thumbs up on that one? Okay, now, this one's a little bit different. Now, first of all, these little tick marks mean these sides are equal. So this is definitely half a square. It is a 45, 45. Now, the 12 is sitting right where the x squared to 2 is. Now, this is going to take a little bit of algebra, but that doesn't scare me. So the 12 is sitting where the x squared to 2 happen to be. So if I need to find x, I have to solve. Okay, so I'm just going to divide by the square root of 12. So if I said that wrong. Divide by the square root of 2. If I want to solve for x, let's divide by... Okay, divide by the square root of 2, divide by the square root of 2, okay? Now, x will equal. So when you go 12 divided by the square root of 2, you get the square root of 6, okay? And I'm going to show you why that works, okay? A little side work. I'm going to show you a little bit of algebra. Why is 12 divided by the square root of 2 become the square root of 6? Well, you guys don't probably remember this, but a long time ago, Mr. Bard probably showed you how to rationalize square roots. Okay, it's been a long time, but I'll show you again. The rule is you can't have a square root in the bottom. Do you remember that at all? Did he teach you that? You're not supposed to have a square root. So you fix, here's how I teach it. If you can't have a square root in the bottom, you fix the problem with the problem. So I multiply the square root of 2 over the square root of 2. That's how you fix it. Did he show you that? Yes. So what happens is you get 12 square root of 2 divided by the square root of 4. See the square root of 4? The square root of 4 is just 2. And then the 12 divided by 2 becomes your 6 square root of 2. Okay? Alright, moving forward, okay? Let's look at the example 4. Okay, it's a 30, 60, 90, right? So if it's a 30, 60, 90, I'm using this triangle here, right? Want to use this one. So if this is 5, the hypotenuse is twice as big. This is 10. If this is 5, the longer leg is 5 times the square root of 3. That's it. It's easy. Okay, somebody knocked this one down, but it's still a 30, 60, 90, right? It just got tipped over. If this is 12, that's the longer side, that's hypotenuse, so the short side's got to be, half of that, right? And then the longer leg is going to be whatever this is times the square root of 3, so it's just going to be 6 square root of 3. Okay, now, everybody good so far? Okay, 6 is the hard one, because I need this to be some square root of 3, but it's not. It's an 18. So 18 is really where the x square root of 3 happen to be. Okay, I need to find x, so solve for x. So what do? Well, let's solve for x by dividing by the square root of 3, dividing by the square root of 3, because that'll cancel the square root of 3, right? Cancel that out. So I'll be left with x equals, well, 18 divided by the square root of 3 is going to be the square root of 6, okay? Nope. It's 6 square root of 3. Yep. Sorry about that. I did make a mistake. Do that every now and then. And I can show you why it's 6 square root of 3. Do a little side work over here. So if I have 18 divided by the square root of 3, I want to show this to you, okay, because you're going to need to know this for Algebra 2. You can't have a square root in the bottom, right? That's one of the rules. So how do you get rid of it? We fix the problem with the problem. We multiply by square root of 3, square root of 3, right? And I wind up with 18 times the square root of 3 over square root of 3 times square root of 3 is square root of 9, right? Square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3, and 18 divided by 3 is 6, okay? Now, let's go back to this. I'm not done. If this is 6 square root of 3, this is twice that. This is a 12 square root of 3. Don't multiply the 3, because that's a square root. Just double the 6, okay? Thumbs up, sideways, where are you at in this whole thing? I see a thumb up. I see 2 thumbs up. That's awesome. Okay? Okay, kind of, yeah, okay. It's these ones are hard, right? But all the rest are pretty easy. You guys agree? Most of your homework is going to be the normal ones, okay? You won't see too many of these in your homework, okay? Ready to turn the page? All right. I like this problem. I like it so much you'll probably see it again someday, because it really is a pretty simple problem. It really is. How do I know? Area of a triangle. Isn't area of a triangle 1/2 the base times the height? Isn't that the area of a triangle? 1/2 base times height. But I don't know the height. I don't know the height, but I do know that if I were to look at half this triangle here, since it's an equilateral triangle, okay, I'm just going to take this triangle and superimpose it, okay, here it is. And since it's an equilateral, when I bring the height straight down, it is at 90. You guys okay with that? It's an equilateral, so it was 60, 60, 60, right? It was 60, 60, 60, but now it's a 30, 60, 90, right? I know this is 10, okay? I'll slow down for a second. Okay, you follow my reasoning? Cut it right down the middle to make a right triangle, right? It's equilateral, so that I know that's 60, 60, 60, but I cut it right down the middle, so I make it 30, 60, 90, okay? Oh, wait a minute. That's a special right triangle, isn't it? Hey, it's that one right there, right? So if this is 10, this side is 5. I kind of knew that anyway, didn't I, right? And what's the height?
5 square roots of 3.
5 square roots of 3. So now I can take my area, right? So my area is equal to 1/2 the base, which is 10, right? Times the height, which is 5 square roots of 3. Okay, so check it out. There it is. We've got 1/2 the base, which is 10, times the height, which is 5 square roots of 3. And now half of 10 is 5, times 5 is a 25 square roots of 3 is the area. And then call it centimeters squared or whatever. Now that's a great answer. That's an answer a math teacher likes. Okay, Most people don't like that answer. So if you want to go to Marston's and say, okay, well, I need a board 25 square roots of 3 inches squared, they'd say think you're crazy. So you could get a decimal answer and call it about approximately equal to 43.3. Okay. Now, this one could have been done by Pythagorean's theorem. You agree? You could have gone, all right, a squared plus 5 squared equals 10 squared, and you could have solved for that, right? You could have, and you would have got a decimal answer, which would have been fine, except so much faster. And it works only because it's a 36-centimeter triangle. So much faster, okay? Now, let's check out the last one, okay? Again, I like this problem. You know why? In a hexagon, I've got 6 triangles, right? Now, it's a hexagon, right? So let's do a little bit of thinking here. I know I can go in a circle 360 degrees. You guys agree with that? So that means this has got to be 60, 60, 60, 60, 60, 60. How am I doing, right? I know this side is equal to this side. Do you agree with that? Do you agree that side's equal to that side? Which makes this angle equal to this angle, doesn't it? So let me just, for the fun of it, draw this one triangle a little bit bigger than all the rest, okay? 60 degrees, right? That side's equal to that side. So what do these two angles here have to be? Sarah, say it. You're right. It's got to be 60, 60. You guys agree? Hey, it looks like the triangle up here, doesn't it? Looks like that triangle up there, except for with one small difference. This is not 10, 10. This is 12 and 12. Right? And this is 12. Okay, if I can find the area of this one triangle, I can multiply it by 6 and get the whole thing. Does that make sense? If I can get the area of this triangle, I multiply by 6 and get the whole thing. Okay, so how am I going to do that? Well, I know the area of a triangle is 1/2 base times height. Okay, what's my height going to be? 6 square roots of 3. Wow, how did I get that so fast? It's my special right triangle, isn't it? You guys see my special right triangle? So I know that's 12. This is 6, right? That's 12, that's 6, and that's 6 square roots of 3. So, area, 1/2. 12 times my height, which is 6 square roots of 3. If I get half of 12 is 6, times 6 is 36 square roots of 3, okay? Half of 12 is 6, 6 times 6 is 36 square roots of 3. Now that's the area of the triangle, okay? That's my triangle area. So the entire hexagon, so my hexagon is going to be 6 times my 36 square roots of 3. Is that 108? 36 times 6. 216. Wow, I'm glad I used a calculator, huh? So I get 216 square roots of 3, which is an answer I like. Being a math nerd, I like that answer, okay? Now, of course, if you go to Marston's, they're going to say, what in the heck are you talking about? Because they are not math nerds. So I'm just going to go square root of, whoops, that's the wrong button. Square root. I'm going to take my 216 square roots of 3 as a decimal. It's about 374.1. I like that answer better. You probably do also, because then you don't have to use a calculator, right? Not only that, but that's exact and that's a decimal, okay? How's that? Thumbs up? Sideways? Kind of, okay. All right, good. Homework. Page 360, 1 to 18, odd, and 45, okay? So please